In this video presentation, we will look at a typical intersection, the superalignments that make up that intersection, the computators, and the chains that are used to achieve the automation often seen in 12D demonstrations. We will first look at road 3. It is linked to road 5 superalignment and a super CAD string that is made up of two vertices on top of each other, as a segment needs to be defined in order for this to be used in a computator. The horizontal geometry for road 3 is a new computator fixed line point drop reference. This computator remains perpendicular to road 5, dropped from a point, in this case the super CAD string. Road 3's vertical geometry is also linked to road 5 through a computator point grade, where the fixed point cut string is the road 5 centerline, and the grade set at -3. The curb return running from road 5 to road 3 is made up of 3 horizontal element parts. Parts 1 and 3 are the new V9 segment reference computators. They drop a point onto each alignment to define what sort of segment is to be used, in this case a line, in this case an arc. Each has an offset for the road width. Joining those two computators is the free arc or fillet radius set at -10 for a left-hand orientated curve. Our second curb return from road 3 to road 5 is made up of a computator fixed arc type fillet. The approach and departure use the new fixed segment option discussed prior in this superalignment. Note the new highlights for this type of element. Again, a drop point onto the alignment to determine the type of segment required, and the radius to complete the turnout. The cul-de-sac alignment is made up of 5 parts, the first and last again the reference segment type. The 2 free arc fillets and the bulb is defined as a fixed arc reference center radius, where the fixed point is linked to the end of road 3 and the radius specified. Both the curb returns and the cul-de-sac get their vertical geometry from the usual running of a curb return function. The first chain for our intersection is called intersection align. Here we are resolving superalignments, road 3, the curb returns and the cul-de-sac in the user-defined order. Road 5 has not been included as we are going to use this chain inside the alignment editor and the solving solution for road 5. Under the Properties panel in the road 5 editor, there is the option to include a chain in the solving process of road number 5. This is the chain for the previous alignments. Keep the chains used here simple, remembering that whatever you chain together will be run every time the superalignment solves. The chain feature in a superalignment is controlled by an env variable called super_alignment_chain_mode_4D. Its value can be set as 1 for the chain to run at set command, or 2 for the chain to run automatically. With ours set to 2, we can do the auto process, edit our road 5 alignment string, moving the IP, and the resulting alignment strings adjust using the internal chain. The second chain that we will look at includes the alignment chain and a chain that defines the apply minis for roads 5, road 3, the curb return functions for each curb return in the cul-de-sac and the apply many functions that are linked to the curb returns and the cul-de-sac. With a redraw all views at the end of the chain. We can now move the super CAD string that controls the center of the cul-de-sac and the position of the road 3 alignment string. And run the complete intersection chain.